In this lesson, we will focus on the aerodrome characteristics which govern the performance of the aeroplane. Characteristics such as runway length, width, and slope play an important part in determining not only the type of aeroplane that can operate from the aerodrome, but also what the actual minimum performance of these aeroplanes should be. First of all, a runway is not just a simple length of pavement. There are various distances associated with runways that need to be carefully explained and understood. The first of these distances that we must consider is the takeoff run available, otherwise known as TORA. The takeoff run available is defined as the declared length of runway, starting at the point from which an aeroplane can commence the takeoff and ending at the nearest point which is unsuitable to bear the load of the aeroplane under normal conditions. In most cases, the takeoff run available is essentially the paved length of runway from one threshold to another. However, there are instances when the takeoff run available is not the length of paved runway, or in fact the distance from one threshold to another. For instance, large aeroplanes will use a portion of the runway to turn and line up ready for takeoff. As such, the start point of the takeoff will be some distance in from the edge of the pavement. Due account of this must be made by the pilot. In such cases, the actual takeoff run available will, of course, be less than the paved runway length and the distance between the thresholds. This type of takeoff run available reduction is published in the aeroplane flight manual and not in the aerodrome information documents. Reduced TORAs can also result from the close proximity of the runway edge to obstacles or roads. It would be unsafe for an aeroplane to apply full power when it is so close to such features because of the dangerous effects that jet blast may produce. As a result of these considerations, the threshold is not at the edge of the paved surface, but a little further in as shown here. However, the two most common reasons for TORA to be less than the length of paved surface is either because there is a variation in the runway surface strength, or because there is work in progress. When the threshold is not at its usual position on the edge of the paved runway, it is described as a displaced threshold. Information about the TORA would be published in the aerodrome charts, like the one shown here, but temporary changes in takeoff run available length because of maintenance or work in progress would be published in the NOTAMs. Always consult the NOTAMs so that you are kept up to date about the latest changes to the aerodrome conditions or to the airspace in which you operate. It may seem a very obvious statement to make, but you must ensure that your takeoffs are accomplished within the distance legally available to you, in other words, within the takeoff run available. Unfortunately, there have been many cases where, due to unforeseen circumstances involving engine or system failure, an aeroplane has gone beyond the limits of the paved surface and with catastrophic results. At most aerodromes, it is just the TORA that will be available to use for takeoff. But at large commercial aerodromes, there are other runway designators other than TORA which you need to understand. For commercial and operational reasons, there may be an extension to the runway called a stopway. A stopway is the defined rectangular area beyond the end of the TORA in the direction of takeoff, no less wide than the runway and centered upon the extended centerline of the runway, able to support the aeroplane during an aborted takeoff without causing structural damage to the aeroplane, and designated by the airport authorities for use in decelerating the aeroplane during an aborted takeoff. A stopway is regarded as being provided for infrequent use, and it consequently need not have the same load-bearing or wear-resistant qualities as the runway with which it is associated. In some cases, the natural surfaces will be adequate, while in others some land drainage, perhaps ground grading, or even light paving may be required. At some aerodromes, a stopway comprising of natural surfaces may be usable only on a seasonal basis. It is essential that you check the aerodrome information for such details. A stopway may be an economical substitute for what would otherwise have to be provided as paved runway to meet takeoff field length requirements of some aeroplanes. When comparable field lengths are required in each direction, it will be necessary to have a stopway at each end. Stopways cannot be used for any other purpose than bringing an aeroplane to a stop after an aborted takeoff. When lining up, a pilot must taxi to the threshold and start his takeoff run from there. Even if a pilot is taking off from the other direction, he cannot use the stopway as an extra length at the end of the takeoff run. Even when landing, the pilot must not use the stopway, either to land onto or use to come to a stop. To help the pilot recognize the stopway, it should be distinctly marked, as shown here. As a rule, the takeoff or landing run should always be started or stopped at the threshold. There is one exception to this rule. If a pilot sees the runway markings shown here before the threshold, then he may use this marked portion of the runway for the initial takeoff run, but it must not be used for any other purpose. There is one other additional type of extension that can be made to a runway. This is called a clearway. A clearway is defined as a rectangular area beyond the end of the Torah, not less than 152 meters wide, centrally located about the extended center line of the runway and under the control of the airport authorities. The clearway is actually the area underneath the clearway plane, which extends from the end of the runway with an upward slope not exceeding 1.25%, above which no obstacle or terrain protrudes. However, threshold lights may protrude above the plane if their height above the end of the runway is 0.66 meters or less, and if they are located to each side of the runway. The length of clearway will be the lesser of the following two distances: the distance to the first upstanding non-frangible obstacle, or frangible objects of 0.9 meters or more, or a distance equivalent to 50% of the Torah. However, some clearways are longer than 50% of the Torah. If this is the case, a pilot must not use this extra amount in his performance calculations. To summarize, a clearway is designed to be an area free from objects which may cause hazard to an aeroplane in the initial phase of flight, particularly in emergency situations. The clearway serves no other purpose and therefore may not be used as an extension to the landing area or stopping area. Having discussed the extra runway extensions of stopways and clearways, we will now focus on three more specific distances, other than the Torah, which you will need to understand. The first of these distances is the accelerate stop distance available, or ASDA. This used to be known as the emergency distance available. The accelerate stop distance available is the distance from that point on the runway at which the aeroplane can commence its takeoff run to the nearest point in the direction of takeoff, after which the aeroplane cannot be brought to rest in an emergency without the risk of accident. At most aerodromes, the ASDA will be the same length as the Torah, as illustrated here. However, if there is a stopway present, the ASDA can be increased beyond the Torah to include the stopway. Remember though, the ASDA is to be used solely for the rejected takeoff. This will be covered in detail, particularly when we deal with the medium-range jet, the Boeing 737, in the Class A section of this course. In simple terms, the ASDA is equal to the length of Torah plus the stopway if a stopway is present. The second of the specific distances that a pilot needs to understand is the takeoff distance available, normally abbreviated to TODA. The takeoff distance available is that distance from the point on the runway at which the aeroplane can commence its takeoff run to the nearest obstacle in the direction of takeoff, projecting above the surface of the aerodrome and capable of affecting the safety of the aeroplane. At most aerodromes, the TODA will be the same length as the TORA, as illustrated here. However, if there is a clearway present, the TODA can be increased beyond the TORA to include the clearway. You may recall that there was a maximum permissible length of clearway which equated to 50% of the TORA. This makes the maximum possible TODA 150% of the TORA. In simple terms, the TODA is the TORA plus the clearway, if such a clearway is present. The last of the specific distances we need to mention is the landing distance available, or LDA. The landing distance available is the length of runway which is declared available by the appropriate authority, commencing from the point on the surface of the aerodrome above which the aeroplane can commence its landing run, and extending to the nearest point in the direction of landing, beyond which the surface of the aerodrome is incapable of bearing the weight of the aeroplane under normal operating conditions. The LDA stretches from one threshold to another. There is no other distance that is allowed to be used for landing. Even stopways are not to be used. They are only to be used for an abandoned takeoff. Having learnt all the various individual distances available at an aerodrome, there is one last item to consider. A runway for which the accelerate stop distance available is equal to the takeoff distance available is considered to possess what is called a balanced field length, or more simply, a balanced field. In the case on screen, there are no stopways or clearways, but a field may also be balanced when the stopway and clearway are of equal length. In such a case, the ASDA and TODA are still the same. The term is used because many takeoff performance calculations can be simplified by using balanced field lengths. We will consider balanced fields when dealing with takeoff in the Class A section of this course. When the TODA and ASDA are not the same lengths, as in the case illustrated here, we are dealing with what is called an unbalanced field.